Hey guys, it's Mr. Sheeling here. So I was thinking about this and I thought that, you know what, I don't think it is enough to give you guys just the key for this acceleration worksheet number 1. So I'm going to walk you through how it is that you should be calculating these problems. So we have a whole, assortment of kind of problems here we're going to be finding. Here, sorry, I'm going to have to move this a little bit. Sorry about that. Here we're going to find acceleration, we're going to find final velocity, do we find initial velocity? Yeah, we do find initial velocity, and we find time. So we see a big old mix of pretty much all the things that deal with acceleration we find in here. And, I wanted to actually walk you through this rather than just, like I said, rather than just throwing the key at you. Just in case there's still something you're not understanding, there's still something that you're just, somewhere something's not clicking. Okay, so now, before I get going on this, just remember, as always, yes, you do have the key. Yes, I'm going to be walking through these problems. However, this is not something that I just want you to sit by and just watch. I want you to complete this on your own first. Then, after you've completed this, then I want you to come back. I want you to watch the video, if you need to watch the video. Watch the video, see where it is that, you are doing things incorrectly. See where it is that things are not going correct or going right, okay? And use this to help you. Watching this, just listening to this, is literally doing nothing. It's doing more than nothing. It is probably actually counterproductive, to be frank. I'm sorry, and I know this is turning into a little rant, but the whole visual, auditory kind of learner kind of thing, okay, yes, there's some truth to it, but realistically speaking, I'm sorry, there's really not an argument that you only learn from one. There actually is no argument, because that wasn't what was originally meant or said in the idea of those 3 types of learners. You need to do this on your own. That's how you practice. That's how you understand what's happening. That's where you get the skills. Listening and just watching, haphazardly, that's doing nothing for you. So please finish this, then come back, and then see what it is that I'm doing. Okay. So, all right. So looking here, up at the top, just wanted to give you these reminders, what the final velocity is, what the initial velocity is, and I give you just the original acceleration formula here, equation. So remember, in the notes, though, I give you the equation on how to find final velocity, and I also give the equation on how to find initial velocity, and I also give you the formula on how to find time. So make sure you've got your notes right next to you so that we can use those notes with this worksheet. Okay, so let's take a look at this. So if an object, looking at number 1, if an object accelerates from rest with a constant acceleration of 5.4 meters per second squared, what will its velocity be after 28 seconds? So I'm going to first break this down into variables, and I'm going to be doing that for all 5 of these. So looks like we're starting at rest. We have constant acceleration, and it's asking about velocity after 28 seconds. So that tells me that we have 3 out of the 4 things here. We've got initial velocity, which is 0 meters per second, okay, because we're starting from rest. We have acceleration, which is 5.4 meters per second squared. Okay, and we're going to say forward. It's got to have those directions. It's a vector quantity, forward. And we have time, 28 seconds. And we're trying to find the final velocity here. What is our final velocity? So I'm going to rewrite the acceleration is equal to Vf minus Vi over time. I'm trying to find this guy right here. I'm going to look in my notes, or if I know how to do this algebraically, I can set it to where final velocity is by itself. So I'm going to set it to where final velocity is by itself. So I'm going to multiply time to both sides. Then I'm going to do the opposite right here. I'm going to add the initial velocity to both sides. It cancels. And so then I'm left with final velocity is equal to time times acceleration plus initial velocity. I'm left with that. So just to solve it, I'm going to plug it in. 28 times 5.4. It's plus 0 because we are starting from rest. And I pop that in my calculator. 28 seconds times 5.4. So that means that my final velocity here is 151.2 meters per second forward. Nice. I'm going to check my key. Exactly right. Okay. Okay. Taking a look at number 2. An object is moving at a velocity of 23 meters per second. It accelerates to a velocity of 85 meters per second over a time of 8.3 seconds. What acceleration did it experience? So let's see. So it looks like here we've got a moving vehicle, or a moving object, I should say. It's accelerating and it's increasing its velocity, okay, and over a time period of 8.3 seconds. And it's asking what is the acceleration, okay. So here, an object is initially moving at 23 meters per second, so that's my initial velocity. Okay, so 23 meters per second, we're going to say forward. And then it picks up speed, so my final velocity is 85 meters per second. So what went from 23 meters per second to 85 meters per second? And it did that over this amount of time. It did it in 8.3 seconds. And so now I'm tasked with finding velocity. Okay. So this one, not too shabby. Just going to write down the acceleration equation. Okay, so there it all is. I'm going to plug everything in. So then it's going to be 85 minus 23 over 8.3. So then it's going to be 85 minus 23. So then it becomes 62 divided by 8.3. And then 62 divided by 8.3 is going to give me 7.47 meters per second squared. Squared because it is acceleration here forward. So what we're saying here is that for every second that goes on, we're increasing our velocity by 7.47 meters per second. Okay. Okay. So again, for every second that passes, okay, 1 Mississippi, we just increased our velocity by magnitude of 7.47 meters per second. Okay. So that's what happened there. And just remember, it's acceleration, so our units are meters per second squared. Okay? So got to remember that. An object accelerates, looking at number 3 now, an object accelerates to a velocity of 34 meters per second over a time of 1.3 seconds. The acceleration it experienced was 15 meters per second squared, and we're looking for the initial velocity. Okay, so looking back at this, so this is what we're trying to find. But looking back at this, looks like it accelerates to this degree, to this rate, to 34 meters per second. And it did it in 1.3 seconds. Here's my acceleration. Okay, so this means that an object accelerates. That tells me that this is the final velocity here. So my final velocity is 34 meters per second. We're going to say forward. Then it gives me time of 1.3 seconds. And then it gives me acceleration here of 15 meters per second squared. I'm trying to find whatever initial velocity we started off with. Okay. So I'm going to break this down algebraically again, or you can look in your notes. I do give you the equation. I do give you the formula to find initial velocity in the notes, so you can look there, or you can follow along algebraically with me. So I'm going to write out my acceleration equation, and I'm going to try to solve and get this guy all by himself. So what I'm going to do, like always, multiply time to both sides, cancels, okay. I am then to get rid of final velocities because I want to keep this. Final velocity, I've got to subtract final velocity from both sides. So then that gets rid of it. Oops, nope, it gets rid of that guy. I still have this guy over here. So then I'm going to write out what it should look like right now. So that means that I've got t times acceleration, time times acceleration minus, but I've got a negative sign over here, so I've got to get rid of that by multiplying -1 to both sides, so that -1 gets rid of it. So then it's going to be a plus and a negative here. So to rewrite it, it's my initial velocity is equal to final velocity minus times acceleration. So why did I move this final velocity from here, from the right of this guy to the left of it? Well, you don't have to. It just makes the equation look a little cleaner, because now we know that this guy is positive now, we know that this is negative now, and this is going to happen. This is the same thing as here. It's just we flipped it. We've got to say that we're subtracting this from this, rather than saying we are adding this to this, but this is a negative number. It's the same thing, okay? So that's why I did that. It just makes it look a little cleaner. So let's plug everything in. So we have 34 minus 1.3 times 15. So I'm going to plot that into my calculator. And make sure when you plot that into your calculator, make sure you figure this first, order of operations. You're going to calculate this first, then you'll, subtract this from this, okay? And what you should get is this. You should get 14.5 meters per second forward after you plot it into your calculator. That's what you should get, okay? Okay. Looking at number 4. A car is driving at a velocity of 24 meters per second. It brakes, at 24 meters per second. If it brakes, can supply an acceleration of -5.0 meters per second squared, how much time will be required to bring the car to a stop? Ooh, so we've got a -1 here. So let's just kind of break this down real quick. So it looks like we've got here, we're starting off by saying that we're starting at this velocity, that our starting velocity is 24 meters per second. And it says here, if it brakes, can supply an acceleration of -5 meters per second squared, how much time will it be required for the car to stop? Okay, so we've got 3 things, and the 4th one is time, and we need to find time because it's asking how much time. So this right here is going to the 24 is my initial velocity, because that's how we're starting off with. We are moving, we've already been moving at 24 meters per second. Okay. And then the acceleration, it's negative. Why would it be negative? Well, it's negative because, and I'm going to write it over here as a positive, because I'm going to tell you the direction is backwards. Okay, this is the motion we're moving in, but the acceleration is backwards. So it'd be like the same as saying, well, we're moving this way, but the brakes are being applied this way. Okay, they're opposing one another. So this is still going to be technically a negative number when we plot it in, but I'm just writing it because this should be implied here that since we're saying backwards, this is a negative number compared to this one. Okay, and we have final velocity. The final velocity is 0. We're saying because we're moving and then we're stopping, and so we're starting off with motion, but we're ending with no motion. So this is our initial, this is our final. Okay, and it's asking, what is time? Okay. So this one, to break this down algebraically, it's a little quicker, a little easier. All we have to do is we just swap t with a. That's all we do. We just switch them. Okay, we're going to put this guy down here. this guy down here. And how I know that is because, you know, what you would do is you multiply t by both sides, and then you just have to divide acceleration on both sides. So it's really just swapping them. Okay. So it turns into this. Time is equal to the final velocity minus the initial velocity over acceleration. So what we should be expecting to see here is like, oh boy, I know that's a 0, so that means my initial velocity is going to be negative. Well, in order to get a positive number here, I better have this as a negative as well down here in order for this to make sense, because you can't really have negative time. So I'm going to plug this in. So my final was 0, my initial was 24, and then it's over acceleration, which is a negative 5. So it's going to be a negative 24 divided by negative 5, which is going to give me time at 4.8 seconds. Okay. Now, if you did 24 divided by negative 5 or negative 24 divided by positive 5, you still get 4.8, but you will be a little, it may be a bit confusing why you would have a negative number. Ultimately, does it matter? No, because, you know, time is not a vector quantity. So, you know, in this case, you really could just ignore the negative and just still say 4.8. But it can confuse you in the future, you know, if you may know that now, but in the future you may forget about it. And it may make you scratch your head a bit when we get back to looking at this, especially like, say, on a test or something. So it's a vector. These are vector quantities. Other than time, they're all vector quantities, and you got to be thinking about direction. You got to be thinking about, you know, how are they affecting one another in the directions that they're going. So, okay. Then number 5, finally, an object is traveling at a constant velocity of 15 meters per second when it experiences a constant acceleration of 3.5 meters per second squared over a time of 11 seconds. What will its velocity be after that acceleration? So here it sounds like we're going to find final velocity, because it says here an object is traveling at a constant velocity. Okay, so that means that we're already moving. So that's my initial. We're already moving here. When it experiences, all of a sudden it starts accelerating. Okay, it has an acceleration of 3.5 meters per second squared. Oh, and this is all forward. Forward. And it does this, it accelerates at 3.5 meters per second for 11 seconds. And we're asked, what is its velocity after acceleration? So what's its final velocity? Okay, we don't know. What is its final velocity? So let's just set this up, because we've already done this. I'm not gonna go through the algebraic form again here. I'm just going to straight up write it out. This is the formula we're working with. Okay, the final velocity is equal to time multiplied by acceleration plus the initial velocity. Okay, so I'm going to plug that in. So then it's going to be 11 times 3.5 plus, and it's not a 0 this time, we actually have a number, it's 15. Okay, so we're going to do this first, 11 times 3.5. Okay, which that's going to give me 38.5, and then plus 15. And then what I'll get here is, for my final velocity, our final velocity is 53 meters for, every second. I forgot to put it forward. Okay. And that is it. Now, quick double check. Yep, 53.5 meters per second forward. Good. 4.8 seconds. Good. 14.5 meters per second forward. Perfect. 7.47 meters per second squared forward for number 2. Perfect. Okay, so it's really not that bad. It's, acceleration. It's just a bit different because we've got different velocities now. So, but again, it's just, always be thinking of this, and your other worksheets are going to have this too, that, final velocity is just whatever you end with. Initial velocity is the velocity you start with. So just first figure out, are we starting with are we starting with initial velocity? Do we have it? Are we at rest? What's our final velocity? And how, what's the rate of that? And then after you have initial and final, then you have to ask, well, how long were we measuring? What's our time? And then once you have all three, you can then use this guy to find your acceleration. Okay, it's not too bad. So anyway, all right, guys. So I hopefully this helps you out a little further. If there was anything you were stuck on, and this shows you how to solve for final velocity, acceleration, initial velocity, and time. So it gives you all four, really, really helpful. And I show you, hey, point these out, write out your variables, then write out your equations. And I know, looking at this, it looks super busy, but hey, man, this takes practice, and you know what? It works, and it's invaluable when you get this practice down now. For when you're in different classes, whether it's math or science in the future. So anyway, if you have questions for me, make sure you get a hold of me. If not, I'll see you in the next one.